Alright, and welcome to our first official edition of Geometries for Squares. Let's just not forget as we go into this, pause the video when you need to pause it, rewind the video when you need to rewind it. I'll probably go fairly quickly just for that reason. I don't have to pause and wait for you to finish copying things down, because you can just hit the spacebar or click the mouse and pause the video when you need to copy down any notes or when you're still working on a problem. There will also be points where I'll ask you to pause to try to work on something on your own, see if you can work through it, just so that you can get that experience and that practice, and then you can resume the video and continue to get the full explanation. Before we launch into today's lesson, I did want to give a little bit of a recap as to where we've been, just so that we can see kind of big picture where we've been, where we are now, and where we're going in the future. So if you recall back in lesson 6.1, we saw this figure here, and this kind of gives us a big picture of the entire chapter. So we're looking at quadrilaterals, and lesson 6.1 was focused particularly on classifying all these different quadrilaterals. And so we looked at major characteristics that differentiates between these different quadrilaterals. And so, you gotta love the flow chart here. We looked at this term quadrilateral, which we said basically just means four-sided figure, right? Quad, meaning four. And then from there we can start to delineate between different types of quadrilaterals. So we looked at, this category, the kite, being a special type of quadrilateral where none of the sides are parallel. We don't have any parallel sides here, but there are some characteristics that we learned about the kite, such as its congruent sides and things like that. And then we said if it has exactly one pair of parallel sides, then it's considered a trapezoid. And here we can see, the bases, in this case the top and bottom, but these two bases being parallel. And we also mentioned a special type of trapezoid that we call an isosceles trapezoid. So that's simply same thing. It's a trapezoid. It's got exactly one pair of parallel bases, in this case the top and the bottom. But the isosceles trapezoid is special because the two non-parallel sides, we see here on the left and the right, are congruent. So that's really the only thing that differentiates between an isosceles trapezoid and just a general trapezoid. And then we said if you have two pairs of parallel sides, so both opposite sides are parallel, then that can be considered a parallelogram. And we'll find several different types of parallelograms. The first one being the rectangle, where we have 90-degree angles on all four angles, but our sides, all four sides, are not congruent. We have opposite sides being congruent here, opposite sides being congruent here, but the two adjacent sides are not congruent. Whereas a rhombus, all four of our sides are congruent, and I know this probably isn't the greatest picture of a rhombus because it doesn't quite look like all four sides are congruent, but all four sides are congruent. They're also both pairs of parallel sides are parallel, so we know it is a type of parallelogram. But here we see that we don't have 90-degree angles. So in this case, we'll find that opposite angles are congruent here, opposite angles will be congruent here, but all four sides are congruent. And then the last one being the square, the most specific that we'll get, where we have all four sides being congruent as well as all four angles are 90-degree angles. So if you're reading this properly, you can see that all of these things down here are all types of quadrilaterals. An isosceles trapezoid, in the same token, is a type of trapezoid. Rectangle, rhombus, and a square are all types of parallelograms. And if we want to get even more specific, a square is a type of rectangle. So you can say a square is a rectangle, and you can say a square is a rhombus. But you can't necessarily say that a rhombus is a square, right? Because some rhombuses, not really sure how to say that plural. Some rhombuses do not have the 90-degree angle, so they may not be considered a square. So you have to be careful a little bit when you characterize these things, but we do want to be as specific as possible. If we saw a square and we saw that it was labeled with all four sides congruent and all four angles are 90-degree angles, and we just called it a parallelogram, we're not really giving as much information as we can about that figure. So we really should be as specific as we can. So that was lesson 6.1, where we classified all of these different types of quadrilaterals. From there, we went on to lesson 6.2, where we started talking a little bit more about this group in particular here, the parallelograms. And we started looking at some properties of parallelograms, such as the opposite sides are congruent on all parallelograms, the opposite angles are congruent, and we also found, when we looked a little closer, that when you draw the diagonals, so when you draw a diagonal from corner to corner here and from corner to corner here, when you draw those two diagonals, we find that they bisect one another, meaning they split each other in half. And that's true for all parallelograms. So you can do that for squares, for rectangles, for rhombus, and you'll always find that those diagonals bisect each other. So those are some useful properties of parallelograms if we know that both pairs of sides are parallel. Then in lesson 6.3 we went on to look at how can we determine if a quadrilateral is a parallelogram. So if we have a shape and we have just a little bit of information about it, and we know that it has four sides, how can we determine if it's a parallelogram? And so we looked at several different ways. We said if both opposite sides are congruent, then we know it's a parallelogram. So if we're only told that these two sides are congruent and that these two sides are congruent, we can still make the conclusion, we can prove that that shape is a parallelogram, and therefore all those other properties are true, the bisecting diagonals and the congruent opposite angles and things like that. So if we only have that little bit of information, we can still prove that it is a parallelogram. Same thing if we know that both opposite angles are congruent. Right? If we don't know anything about the sides, they don't tell us any information about the sides, but they tell us that both pairs of opposite angles are congruent, we can prove that it's a parallelogram. And then from there, we know that the opposite sides are congruent, the diagonals bisect each other. Same thing with, if we only know that the diagonals bisect each other, we can, again, prove that it's a parallelogram. And then the last way that we found was, if you have one pair of sides, so if we look at the top and bottom here, and we know that the top and bottom are congruent, and that they are parallel, then we can again prove that it's a parallelogram, and all those additional helpful pieces of information about parallelograms would be true about that shape. So 6.3 was more in terms of, if we only have a little bit of information, how can we determine if something is a parallelogram? 6.4 we went on to branch out further from parallelograms and start to look at these special parallelograms. So we looked at rhombuses, we looked at rectangles, and we started looking at some of their properties specifically. We learned a number of things about both. And now as we continue today with lesson 6.5, we're going to branch in the other direction and start to look in more detail at kites and at trapezoids. So that's where lesson 6.5 is going to take us today. As we continue on into the lesson, I did want to first just look at this general shape and remind ourselves of what exactly a trapezoid is. In lesson 6.1 we defined it as a quadrilateral with exactly one pair of parallel sides. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. And once we've determined those sides, for example in our figure here, the top and the bottom side are parallel. And we refer to those as bases. So the sides are legs, and the parallel sides we call bases. And the angles we refer to as base angles. Now, base angles refer to a specific pairing of angles. For example, notice how this mentions base angles, and it specifically means this angle here and this angle here together, because these two angles share this base, right? The base being one of the parallel sides. These two angles down here we call base angles because they share this base, this other parallel side. If we were to refer to this angle and this angle together, we could not call those base angles because they don't share a base, they share a leg. So the base angles specifically refer to the angles that share one of the parallel sides, or the base. So from there we can start to talk a little bit about some of these new properties for trapezoids. Now that we know exactly what a base angle is, we can show that the base angle of a trapezoid, you probably figured this out, they're congruent, right? So those base angles, if they share a parallel side, then they're going to end up being congruent. And we know that as we start to look at trapezoids, we can conclude that the diagonals are going to be congruent. So that's a little bit different. In the past, with the parallelograms, when we looked at those, we found that the diagonals bisected each other, but might not necessarily be congruent. In this case, they don't necessarily bisect each other, but we do find that the diagonals of an isosceles trapezoid are congruent. So again, bear in mind these are for isosceles trapezoids, which we had mentioned when I did the little recap at the beginning. An isosceles trapezoid is where the non-parallel sides, or the legs, are congruent. Okay, so we can see, in this case, our figure here doesn't quite look like an isosceles trapezoid, which is why I didn't point out before, because the way it's drawn, it looks like maybe this leg is a little bit shorter than this leg, but an isosceles trapezoid is one where the two legs are congruent. So we can get our official definition of base angles are the angles that share a base. We said the bases being the parallel sides, right? The legs are the non-parallel sides, bases are the parallel sides. Alright, continuing on, kites. We know kites kind of are the ones that look most out of place. When we come back up here and look at all these figures, it seems like kites tend to be the most out of place of the figures. And part of that is not having any parallel sides. So they look a little bit different from all the other ones that have at least one pair or two pairs. And we don't have any opposite sides that are congruent, right? When we went back in chapter 6.1 and we defined a kite, we said a kite is a quadrilateral with two pairs of adjacent sides that are congruent, but no opposite sides being congruent. So none of the opposite sides are congruent, which just makes it look a little bit different. But we do find that when we draw diagonals of a kite, something interesting happens. They don't bisect each other, and they're not congruent, not always congruent, but we do find that they're perpendicular. So if we have a kite and we draw in the two diagonals of that kite, we're going to find that those diagonals end up crossing to form a 90-degree angle between them. So let's take all these little bits of information that we learned about these special types of quadrilaterals and let's apply it to some practice problems. So if we look at the first one here, we have a figure, and just by looking at it we can guess at the fact that it's a trapezoid, and as we look at the title here, it does tell us in fact that it's a trapezoid, and the directions then go even further and tell us that it is isosceles. So we can make some conclusions about that. We know that if it's isosceles, we can indicate that this side is going to be congruent to that side, right? Based on our definition of an isosceles trapezoid. So it's always good to take whatever information you find in the question stem and go ahead and just mark that relevant information on any figures or diagrams that we have. So as we continue on, the question gives us information about one angle, and that's already marked in here. That angle X is 156, and we're going to continue on to try to find angles Y, Z, and W. So one kind of straightforward approach here is thinking about what we know about trapezoids. And we know that if we look at angles X and W, right, these two angles here, we know that if two angles share the leg of a trapezoid, then those angles are going to add up to 180 degrees, which we say supplementary. So we know that those two angles are going to be supplementary, so they must add up to X plus W. They're going to have to add up to 180 degrees. Another way that we could look at this, if we forget this particular rule about angles that share the leg of a trapezoid, we could think of this as two parallel lines with a transversal. Right? So if you were to extend line XY and you were to extend line WZ, that would be two parallel lines, and then you can consider line XW as being a transversal. And then you see that this angle here for X and this angle here for W are simply same side interior angles. And if you recall from when we talked about parallel lines with transversals, same side interior angles are going to be supplementary. So if you forget this particular rule, there's always another way, which is one of the great things about geometry, is there's often several ways to solve things. So if we substitute in what we know, right, we already know that angle X is going to be 156, so we can plug that in, and we said that those two are going to have to add up to 180. So we can subtract 156 from both sides, and we get 180 minus 156, which gives us 24. Right? So this angle here, W, we know now is going to be 24. And then the easier part to find Y and Z is just recalling that when you have a trapezoid, those base angles of an isosceles trapezoid, not all trapezoids, but isosceles trapezoids, are going to be congruent. Right? And that was one of our special characteristics of isosceles trapezoids that we learned today. So if angle X is 156, then we know that angle Y is also 156 because they share a base, and this is an isosceles triangle. So if angle Z is going to be congruent to angle W because they share a base, and we already know, we just solved before, that angle W is 24. So we've now hit all four of these angles within our isosceles trapezoid. Alright, that one was fairly straightforward with trapezoids. Let's maybe kick it up a notch and take a look at this monster over here. In geometry, they do like to kind of take these shapes and figures and put them all together. So in this case, we can see we've got triangles here in this bottom row. We've got trapezoids going on up here, and then more trapezoids going on up here. And we can look at this a different way as well and look at this whole thing as a triangle, right? So from the vertex down here all the way up to A to B and then back down to the vertex, we could consider a large triangle. So lots of different ways to look at this. We could also consider from this point here up to A to B down to this point here and back over as, again, just another type of trapezoid. So if we look at this, they call it a spider web. It does kind of resemble a spider web. And it says that it's formed by layers of congruent isosceles trapezoids. So that gives us even another bit of information. We can see our parallel sides here, right? So there's a base, and there's a base. Or if we're looking at the outer layer, there's a base, and there's a base. But the fact that they tell us that this is isosceles means that we can conclude that the legs are congruent as well. So this leg would be congruent to this leg would be congruent to this leg, and all the way around. So they want us to find the angles up here at A, B, C, and D. So it says here the trapezoid ABDC is part of an isosceles triangle whose vertex is at the center. So like I mentioned before, we can look at this whole thing as one big triangle. So the little triangle plus the two trapezoids can be looked on as one big triangle. And if all of these So this side, this leg and this leg are congruent, this leg and this leg are congruent, this leg and this leg are congruent. We can look at this whole figure as being from B to the vertex is congruent from A to the vertex. So it's one big isosceles triangle. So we have these triangles here, and these angles A and B would be the base angles of the isosceles triangle, that bigger triangle there. If we look at these angles in the center here, we should be able to figure those out, right? With this forming a straight line along here, we know that the measure of all of these angles together must be 180 degrees, right? They're going to be supplementary. So if we look at all of these angles together, and we have been mentioning that all of these are congruent, so there's 1, 2, 3, 4, 5, 6 angles in the center there. So those 6 angles all being congruent and forming 180 degrees. We can take that straight angle and we can divide that 180 degrees by the 6 angles that are there. So 180 divided by 6, that's 30 degrees. So each one of these angles in the center here we found to be 30 degrees. So now we can take this and look at our, our triangle up there as a whole. Right? So if we look at this as one big triangle. Practicing my tracing skills here. Okay, so we found this to be 30 degrees, and now we can look at this as one big isosceles triangle. And if we if we were to throw a triangle in here, so let's just pretend that that is the triangle that we just found. We know that when a triangle is isosceles, meaning 2 of the sides are congruent, we know that the angles that share the base are also congruent, right? That's one of those properties of isosceles triangles. So we know in this case that angle A will be congruent to angle B, right? Because this is one big isosceles triangle. So we also know that based on the fact that this is a triangle, we know that angle A plus angle B plus this angle down here, which we already found to be 30, so A plus B plus 30, are all going to add up to 180. Right? So together, A and B will be 150. We subtract 30 from both sides. We know that if this makes up 30, then these two together are going to make up the rest of the 150. Based on what we just talked about with isosceles triangles, though, we know that A and B are congruent. So we can consider them the same. A is equal to B. And we know that 2 of those angles must add up to 150. So if A and B together are the same, and together they make up 150, we know that each one is going to be 75 degrees. So we found our A and our B. Now it's just a matter of finding C and D. A couple ways we can do this. Here it says another way to find the measure of each acute angle is to divide the difference between 180 and the measure of the vertex angle by 2. So here they're redoing this part. They're just taking 180, which was our whole triangle. They're subtracting 30, which was our angle down here, and they're dividing by 2 to get 75, which is essentially what we did up here. They're just putting it all together in one formula instead of taking several steps to get down to 75. Now, the other thing to bear in mind, because we still have to find C and D, right? We have to find these 2 angles in here. But we know C and D, if we can erase this a little bit and look at a different shape now, right? We can see that C and D make up 2 angles of this trapezoid. And we said that these are all isosceles trapezoids where the 2 legs are congruent. So we know a little bit about isosceles trapezoids, and we know that in an isosceles trapezoid, we know that the 2 angles that share the leg are going to be supplementary. And that's actually in any trapezoid, not just isosceles. But in this case, we do have isosceles. So we know that C and D C is going to be equal to D. Right? They're going to be congruent because this is isosceles, but if we look at A and C, we know that together A and C are going to be supplementary. So we can take 180 minus 75, which is what we found for A, and we can get 105 for angle C. So angle C is 105, angle D is also 105. Angles A and B are 75. Alright, I'm going to let you guys try the quick check problem on your own. So quick check number 1 there, it says in the isosceles trapezoid, the measure of angle S is equal to 70. Find P, Q, and R. So don't forget this is isosceles. You can see the marks here and it mentions it here. This is 70, so use the properties that we learned and determine the angles of the other 4 angles. Again, pause it, work through it. You can go back and look at the properties again, or just look back in your notes in your workbook. Give that a crack. This will be one of the ways that I can tell tomorrow that you've actually gone through and done all of this work, is if you have this quick check worked out. We're going to move on to the next example. So we've been working with trapezoids, now we're going to do one working with kites. And we said here they want us to find angles 1, 2, and 3 in the kite. They give us one angle down here. And the main thing that we learned about kites in this lesson was that when we look at their diagonals, they form 90-degree angles. So we know right away, we can get number 2 right away to be 90 degrees because we know that it's a kite and we know that the diagonals are going to be perpendicular. So 2 is an easy one, but we also know, that means that we know that this angle RDU and SDR and SDT are all going to be 90 degrees. So that can help us a little bit further down the road as well. If we look at a kite, we know that the 2 of the adjacent sides are going to be congruent. In this case, the way that it's labeled, we can see that RU is going to be congruent to RS. Right, so RU and RS are going to be congruent. It's marked up there, and that's part of the definition of a kite. And so when we look at the isosceles triangle theorem, right, RU and RS form 2 legs of an isosceles triangle. Right, this big triangle here, RSU, would be an isosceles triangle. And just as we mentioned on the previous example, if we have an isosceles triangle, the base angles are going to be congruent. So if this angle here is 72, we also know that angle 1 will be equal to 72. Okay? So just by looking at the fact that this is an isosceles triangle. Now as we continue on down here, so we've got angle 1, we've got angle 2, we're trying to find angle 3. Well, we know that this angle 3 is part of a smaller triangle, RDU. So if we look at this half of the isosceles triangle that we looked at before, we know that angle 3 plus RDU, this angle in the center here, plus 72, this angle that we found here, should all add up to 180 degrees, right? That's our triangle angle sum theorem. They must add up to 180. Well, we already mentioned before that because this is a kite, those interior angles, right, where the diagonals cross, are all 90 degrees. They meet at a perpendicular angle. So we know RDU is 90. So we can plug 90 in here for RDU. Now we're getting somewhere, right? Those all add up to 180. Combine 90 and 72, we get 162. Subtract from both sides, and we get angle 3 is equal to 18. Alright, so moving on to these quick check problems. Again, I'm going to let you guys tackle these quick check problems at home. That'll be how you show me that you've been doing your work. So we've got one that kind of looks like our spider web. So if you need help with this one, you can head on back to the spiderweb problem that we did, the example, and use that as kind of a guide to work through here. We have sort of a similar pattern of shapes showing up in this situation. And then we've got the last one that resembles our kite that we can do. So the quick checks definitely just echo the examples that we looked at. So for the first quick check, look at the first example. For the second quick check, look at the second example, and so on. Again, if you need any additional help or if you have questions, be writing down your questions. Make sure that you jot down any issues that you have so that we can address them in class as we do additional practice. And just make sure that you have your workbooks completed, including the quick checks for class tomorrow.